Howdy AGP students, this lesson will cover coordinate geometry and slope. Coordinate geometry constitutes any problem related to plotting points on a coordinate plane. Anytime you deal with these types of problems, take the time to draw a neat graph. Visualizing the information can pay huge dividends. The edge of your calculator can be used as a nice straight edge. Oftentimes you may be asked the distance between 2 points. If you make a graph, you can construct a right triangle and solve for the unknown side using the Pythagorean theorem. You can also use the distance formula presented here, where d equals the square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Be careful to use the correct x and y values when using this formula. Other times, the problem may require you to find the midpoint of a line. Again, drawing a graph and plotting points will give you the midpoint, but the formula presented here will also work. To calculate the midpoint of both, add both x values and divide by 2, and do the same for the y values. This will give you the new ordered pair. When dealing with lines, slope measures the steepness of the line. This is often referred to as rise over run, and is represented as m in the standard form of a line, y equals mx plus b. To calculate the slope, you must have 2 points on the line. Use these 2 points to calculate the change in y over the change in x. The traditional formula is presented here as y2 minus y1 over x2 minus x1. This is another formula you must have correct, y and x values arranged together and be consistent. If you use the slope formula, remember to always place the y values on top. Be consistent when ordering the x's and y's. You should also be very careful with your negative numbers. The SAT knows this is a struggle for students and often requires it to be done. It's very important that you be neat with your graphs and you draw them to scale for counting purposes. A neat graph goes a long way. You should also be able to eyeball the slope. Just by looking at the line, you should be able to immediately know if the slope is negative, positive, neutral, or undefined. One way to think about the undefined and the zero slope are to think about skiing. If the terrain's flat, you can ski it and it has a slope of 0 or no slope, so a horizontal line has a slope of 0. If the line goes straight up and down, you can't actually ski that, right? So that slope of the vertical line is undefined because it's impossible. Positive, neutral, and negative slopes are presented here. The graph to the left shows a line with a positive slope. Here you can see that the line is going up and to the right, and this indicates a positive slope. The middle graph has a neutral slope, where y is constant. This has a slope of 0. The graph to the right has a negative slope, and you can see it's always going down and to the right. So that's how you can easily tell if a line's slope is positive or negative. If the line is very steep, or y is changing faster than x, the slope is greater than 1. If y and x are changing at the same rate, the slope is equal to 1. And if x is changing faster than y, or the line is relatively flatter, the slope is less than 1. And those are all here. So here with the slope greater than 1, y is actually changing faster than x. Here, they're changing at the same rate where the slope equals 1, and where the line is flatter, x is changing faster than y. For parallel lines, the slope is exactly the same for both lines. However, perpendicular lines, they have a negative reciprocal slope. So if one line is negative 1/2 is the slope, the perpendicular line would be 2 over 1. So you'll see this in an example later. Let's take a look at our first example problem. Example 1 reads, distance between points P and R is A1, B3, C4, D 2 root 5, and E 4 root 5. And so we have this graph set up over here, so I would anytime you need to, if there's not a graph provided, go ahead and draw one out. But in this question they actually provide the graph. And so you can see these 2 points here, and they actually even give you the triangle set up. So here you can easily do the Pythagorean theorem to find the distance between P and R. And so we'll start with a squared plus b squared equals c squared. Now we can plug in both of our legs, 2 and 4, and we'll square each of those. So we'll go ahead and take 2 squared equals 4 plus 4 squared equals 16, and that'll give us 20. So we'll go ahead and plug that in. 16 plus 4 is 20, and 20 equals c squared. And now we'll take the square root of 20, and that's going to give us 4.47. And now we'll go back to our answer choices and look and see what actually equals 4.47. So we can see here, if we multiply the root of 5 by 2, we'll get 4.47. So let's go ahead and do that. 5 root times 2, and that's going to equal 4.47. And so answer choice D is the correct answer. Now let's move on to example problem 2. This problem states, the diameter of a circle has its endpoints located at -4, -1, and 6, -1. If 1, k is also a point on the circle, and k is greater than 0, then k equals what? And we have a of 3, b 4, c 5, d 6, and e 7. So in this instance, they don't actually give us a graph. So we want to start by making a graph so that we can plot this circle and then find out where we can find this value of k. So let's start, and we'll draw a graph, and we'll plot these points that they give us. So the first point they give us is -4, -1. So we have a point right here, -4, -1, and then we have 6, -1, which is right here. And so we can look at this and we can see that the center of the circle is here at 1, -1, because we have a radius of 5. So if we have a point at 1, x of 1, which we can see right here, the x of 1, and k is greater than 0, so it's going to be in this quadrant here, we can just go up and see that the answer is going to be 4. So 1, 4, and k is going to equal 4. So let's take a look at our answer choices, and that's actually B. So k equals 4. Example 3 states, find the slope of the segment that connects the points -3, 3, and 1, 2. Now to do this, we want to make sure that we draw a really good graph, plot these points, and then connect a line. And then we can actually find the slope. But you could also use the slope formula. But I recommend that you go ahead, draw a graph, get good at drawing these graphs so that you have some practice when the SAT rolls around. And of course, as always, we'll work this problem in class.